Hi, dear professor. I am Hamidreza Fathollahzadeh. I'm here to explain my part of code from the Capstone project. Sorry, for the main part, it implements a charging station simulator, providing options for users to view logs and delete them and to do the simulation with different weather conditions. And it's actually utilizes the simulator class aligned with weather states and logging functionalities. And for the Java class for charging a station, it's modeling a it's modeling a charging station for electric cars, and it manages a list of charging locations and a queue of cars waiting to charge, and utilizes multi-threading to assign cars to random locations for charging. And this class handles various exceptions related to station capacity and like weather conditions and resource filling. And additionally, it incorporates logging to record events like car arrivals and other things. And in the Java class location, it represents a charging location within a charging station for the cars, and it manages the charging process, including checking occupancy and charging cars based on remaining battery capacity and handling exceptions related to energy distribution and bad weather condition. And for the Java class simulator, it actually simulates the operations of multiple charging stations and electric cars. And it initializes the stations and cars and their locations with different energy sources, and then starts by adding cars to stations based on the station availability and handling other exceptions like the time limit and station capacity. And the Java class, which is abstract class for slots, it's represent a charging a slot with a specific energy source and capacity, and allowing for using energy and handling other exceptions for a slot energy and source distribution. And the Java class solar power slot and other tools like wind power slot, it actually extends the abstract class slot and represent charging a slot with a solar energy or wind energy or other resources for electric energies. And they have different capacities. For example, this solar power slot has the capacity of 100. And yeah, that's it. Thank you.
Hello, I'm Faraz Chahybakhsh, and today I'm gonna explain these line of codes and these classes basically so we can have a basic understanding of what's going to happen. In the car class, we declared the battery class, which defines the battery classes of battery type of cars and how much they have. The car class depends on which type of car and which car exactly, and two electrical battery types that we have here. An electrical Java class here is for harvesting energy through the charging cyclation of the car, and also the different energy sources that we define in this class, solar, water, wind, are the different types of energy here that we declared in the package sources and package cars. We declared those classes. And also moving on to another classes, charging station, which basically is the base class of the charging station that we simulated, and location is for location of the cars and which of them are in which slot, and the simulator is the about the going through on the logic of the code, And slots is also the basic slot that every car is charging on them. The solar power slot, water power slot, and wind power slot are the different energy sources that we discussed earlier. And moving on to the logs class, we have the basic class on, we have the three classes of read, write, and also delete logs. So read and write here are for creating or showing the logs in the debugging area, and also delete log is for deleting any logs that the user maybe wants. And we have here a log text class which contains the different logs throughout a simulation of a charge cycle by car. Thank you.
So I hope you are well. I'm Zahra Paya, and in this video I want to explain briefly about part weather. At first we go to class main. Here we set weather, and weather has three classes: rainy, sunny, and windy weather. And here we actually implement in this way, and sunny in this way, and windy. Then for setting car we go to class simulator, and here we using initialize and start method we create a three charging station, and also some cars A to I with different attributes such as car ID, car name, and battery types, and also locations with different slots. After initialization is complete, we proceed to start working, and then we assign the weather state, defining a main class to and all charging station and locations. Set weather state method is called weather state, and weather state based on this invocation it shows different behavior depending on which class object is it belongs to.